Okay, so there comes some confusion sometimes in factoring quadratics. A quadratic is something that has to the squared power. So when you ask to factor it, there's a couple situations that you see. Most commonly, the situation would be something like 2p squared minus 12p. And if you're asked to factor this, you can't use the quadratic formula or anything like that. It's really just going to be finding a common factor between two terms. So if you have a squared term, especially, or any terms here that are two terms and they ask you to factor it, you're looking for the common factor to pull out. So here they both have a common factor of 2p. So 2p squared divided by 2p is p, minus 12p divided by 2p is 6. So that would be in factored form. It would factor it out. Then there's also the situation we're going to start with just when the leading coefficient is 1, where you're going to have this and ask you to factor. The thing about a quadratic is that when you're factoring, you're going to have two factors, because when you multiply it together, you're going to get a p squared. Okay, so there's two solutions to a quadratic. So you're going to have two, and those two will either be something you pulled out in front and then a linear factor, or it'll be two linear factors. So here we find when the leading coefficient is 1, we can just put k in both of those, because we know that when we multiply k times k, that's going to give us our k squared. Then we need to find how we get these two. These come from multiplying to give you negative 12 and adding to give you positive 1. So I think of all my factors of 12. So 12 has the factors 1 times 12, 2 times 6, and 3 times 4. Which of these will add up to be a value of 1? Well, it has to be 3 and 4 because they're 1 apart from each other. Now we need the answer when we multiply them to be a negative 12, and when we add to be a positive 1, which means we want the larger number to be the positive, and one of them has to be negative. So then we get 4 minus 3 gives us a positive 1, and 4 times negative 3 gives us the negative 12. So this is in factored form. This is not the solution, this is just factored. If you're asked to find a solution, that's when you need to set both of these factors equal to 0. Okay, so some people, I think I've seen a lot of confusion on finding factoring something versus solving for something. So if you're just asked to factor, all you're doing is writing it in linear factors. Let's do one more example, because sometimes sometimes the numbers are a little bit bigger. So let's see. And I actually realized I want to show you one more situation. We've talked a lot about the difference of squares. Okay, this is something, if you can memorize the difference of squares, it comes up a lot in math. I see it come up all the time in calculus, and students that know the difference of squares, it helps solving these problems. It saves a lot of time. So the difference of squares says that if you have two perfect squares subtracted from each other, that you can factor them out as the square roots of each of those functions with 1 plus and 1 minus. So these would equal each other. Okay, so here, for instance, because these are both perfect squares, the square root of 16b squared is 4b, and the square root of 25 is 5. This would factor as 4b minus 5 and 4b plus 5. Okay, because there's some things that happen when you have what's called a, I'll think of the word in a second. Anyway, when there's that word. I hope hopefully you're thinking of the word, the conjugate. These are conjugates of each other. And what happens when you multiply conjugates, let's look at going back the other direction. You get 4b times 4b gives you 16b squared. 4b times 5 gives me a positive 20b. And negative 5 times 4b gives me a negative 20b. And then negative 5 times 5 gives me a negative 25. When you multiply conjugates, these middle terms always cancel out. So you can recognize it kind of tricks you. It makes you think that you're doing one of these binomial ones, that you're factoring something common out of them, but really it's you're able to factor them this way because those middle terms have just disappeared. So you're looking for always the difference of squares is a possibility of being in there. So I think that's kind of the basics of factoring, and we'll have a few more assignments on factoring coming up.